Italian researchers at the Istituto Italiano di Tecnologia, IIT, in Genoa have created the first 3D printed seed robot, called iSeed, that can move around and transform itself autonomously. The robot was created by the researchers of Bio-Inspired Soft Robotics, BSR, lab, coordinated by Barbara Mazzolai, in collaboration with the University of Trento. The iSeed is capable of environmental monitoring and can be used in various fields such as reforestation. The European project iSeed, coordinated by IIT, aims to create innovative robots inspired by plant seeds that can act as sensors for monitoring soil quality parameters and air metrics such as the presence of pollutants and CO2 levels. The first iSeed is inspired by the hygromorphic structure of the seed structure of a South African geranium, Pelargonium appendiculatum. The IIT BSR lab, coordinated by Mazzolai, has been inspired by plants for years. The group focused on studying the movement and dispersal features of seed-carrying structures typical of the Geraniaceae plants. These seeds detach from the plant and, exploiting the hygroscopic properties of the materials they are composed of, they change shape and move independently to explore and penetrate the soil, increasing the chance of germination. Researchers replicated the seed design by using and combining 3D printing and electrospinning techniques. Different materials were tested, such as materials capable of absorbing humidity and expanding like cellulose nanocrystals and polyethylene oxide, coupled to biodegradable and thermoplastic polymers based on polycaprolactone. According to Mazzolai, with this latest research, we have further proved that it is possible to create innovative solutions that not only have the objective of monitoring the well-being of our planet, but that do so without altering it. These biodegradable and energy-autonomous robots will be used as wireless, battery-free tools for surface soil exploration and monitoring. Luca Cecchini, a PhD student at IIT in collaboration with the University of Trento and first author of the study, added that, "This bio-inspired approach has allowed us to create low-cost instruments that can be used to collect in situ data with high spatial and temporal resolution, especially in remote areas where no monitoring data are available." Overall, the iSeed is a promising development in the field of bio-inspired soft robotics. It has the potential to revolutionize environmental monitoring and soil exploration while minimizing the impact on the environment.